Hi there and welcome back to the PilotAware YouTube channel. In this video we'll take a look at carry-on electronic conspicuity devices, obscuration and how to improve their performance. So what is obscuration? Here is a dictionary definition. All electronic conspicuity works using ultra-high frequency radio waves. These types of transmissions all require an electrical line of sight to work properly. The line of sight will be interrupted by things that get in the way, such as metals, carbon fibre or water. Obscuration has an adverse effect on all carry-on equipment, no matter what the type, especially electronic conspicuity devices including PilotAware, FLARM and CAP 1391 devices. But what is airframe obscuration? All EC devices transmit isotropically. This can be thought of as acting like ripples on a pond, radiating in all directions. It's not quite like that, but it will do for this explanation. If the device is incorrectly sited, say on the rear luggage compartment, then the signals will be blocked by the metal of the aircraft and the mass of the occupants. This weakening is also called attenuation. Moving the device to the dashboard or in front of the windscreen will show an immediate improvement, especially to the front quadrants where the chance of a mid-air collision is the highest. This polar diagram shows an improvement in range and direction. However, there is still some obscuration to the rear caused by the fact that it is a metal aircraft. With this understanding, it's obviously much better to use remote external antennas to minimise the obscuration where possible. A word of caution here. All electronic conspicuity antennas must be mounted vertically if they are to work properly. This polar diagram shows an efficient radiation pattern of 360 degrees. It shows very little obscuration or attenuation, and this is typical of an installation that is using remote external antennas with its electronic conspicuity device. GPS signals also operate in the ultra-high frequency band, and so they will be similarly affected by obscuration. Consequently, the GPS receiver must also be located so that it has a good view of the GPS satellites. The top of the dashboard is usually an ideal position for this. An efficient EC device with an external antenna will have a radiation pattern that looks something like this. On the other hand, if the transmitting device is carry-on and doesn't have externally mounted antennas, it will look more like this. Most EC providers will supply installation kits with remote antennas. PilotAware supplies installation kits for both remote internal antennas and remote external antennas. Unfortunately, however, this is not the whole picture. What you can and cannot do depends on what type of aircraft you fly. Firstly, in permit aircraft there are light touch regulations towards making modifications, so there is a lot of freedom to choose what to do. All options are available for permit aircraft. However, on C of A aircraft, approvals need to be sought to make any modifications. Consequently, remote internal antennas are the popular choice unless you have a sympathetic engineer who will fit external antennas for you for future use. However, possible help is at hand. EASA has been consulting to introduce a light touch standard for the installation of non-approved electronic conspicuity such as FLARM and PilotAware. Hopefully this will be introduced in early 2021. The PilotAware atom grid stations pick up all types of electronic conspicuity transmissions. This includes Mode S, ADSB out, with either approved or unapproved GPS, CAP 1391 devices, PilotAware, FLARM and PowerFLARM, OGN trackers and FanNet Plus. These are the devices that can be used as carry-on equipment, and these are the devices that can also have remote antennas fitted. So here is the takeaway advice for installing your electronic conspicuity. Firstly, make sure your EC equipment has line of sight for efficient operation. For better performance, use remote internal or remote external antennas. Make sure your antennas are vertically polarized. check that you are being seen by others at a distance, and understand the limitations of your chosen EC device, what it can and what it can't see. And finally, check the polar diagram of your device. It may look like this, when it could and should look like this. To help measure the effect of obscuration, using the PilotAware Atom Grid network, PilotAware has developed a solution to provide feedback for every electronic conspicuity installation in the United Kingdom. All Atom stations are connected via the secure grid network. They continuously track all types of electronic conspicuity. And just to remind you, these include data collected from ADSB transponders, OGN trackers, PilotAware, FLARM, CAP1391 devices and FanNet Plus. This generates huge amounts of data which is recorded on the PilotAware central servers and is available for analysis. Using this data, it is possible to produce polar diagrams for each individual aircraft and also by the types of electronic conspicuity devices used. To be clear, this includes all EC devices, not just PilotAware. We call this service from PilotAware PilotAware Vector. To use the PilotAware Vector service effectively, the aircraft must have flown for a sufficient amount of time for the network to have picked up sufficient EC transmissions. A rolling 30 days of data is used for the analysis, so the more you fly, the greater the amount of data is able to plot the polar diagram. To get a polar diagram matrix is very easy. Just log on to the PilotAware website and select Vectors. Key in your aircraft's unique ICAO code, select the type of electronic conspicuity required, choose the type of diagram you want, and then tap Go. The chosen diagram will be produced from the available data. This will show if the electronic conspicuity is good, average, or could do better. This is what good looks like. This is taken from an aircraft with an external antenna showing very little obscuration. And this is what average looks like. This one is taken from an aircraft with some obscuration to the front and to the left. And this can be improved by repositioning the antennas. Finally, this is from a poorly performing electronic conspicuity device. This needs to be repositioned to get a much better view of the outside of the aircraft. This will improve obscuration and also the poor range. Or of course, you could use remote external antennas. So when you have flown 2 or 3 times in the last 30 days, visit the PilotAware website, navigate to Vector and see how your electronic conspicuity is performing. Well, that's all for now. Fly safe, fly defensively and keep a good lookout at all times. See you again next time.